The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, so today we're going to finish section 10.4. And your homework will be to finish up 10.4 as well as the chapter review. Tomorrow, Thursday, we'll review. And then on Friday, there'll be no official class meeting. You'll just take your chapter 10 test, which is due no later than 11:59 p.m. Friday evening. Having said that, we're going to go back and do a quick review of some of the things we did yesterday. So let me see here. Oh, come on, gotta get things working. There we go. So we looked at parabolas in the form of y equals a times the quantity x minus h squared plus k yesterday. If a is greater than 0, we have a parabola that opens upwards. The lowest point would be the vertex, also known as the minimum of the parabola. If a is less than 0, the parabola opens downwards. The vertex is at the high point, also known as the maximum of the parabola. There is something called the axis of symmetry that goes right through the vertex, whether the parabola opens up or down. If it's in this form, the axis of symmetry is at x equals h, and the vertex is at h. Okay, so for problem number 18 over in WebAssign, where we have f of x equals -5 times the quantity x plus 3 squared plus k, since a is -5, this thing's going to open downward. And let's see, so a is -5 and h is -3, because if we took x plus 3 and wrote it as x minus something, it would have to be -3, and k is equal to what? Oh, I wrote k here instead of a 4. My bad. Let's fix that. Where's my mouse? There it is. Okay. Oops, I erased more than I needed to there. That's interesting. It doesn't want to let me erase that. Oh, there we go. Okay. I think we're back in business. There we go. Okay. So k is 4. Sorry about that. Now, to graph this thing, let's see. So the axis of symmetry, hold it, is what? X equals -3, and the vertex is at -3, 4. So the vertex is at -3, space 4. The axis of symmetry is an equation. It's not just h or -3. It's got to be written as x equals -3. All right. Now, to graph this thing, we need 2 points. The first point is the vertex. I'm going to go over here to the graph. I'm going to click on the parabola, the one that opens upward until it turns blue. Then I'm going to go over here and I'm going to plot the vertex, -3, 4. Okay. Now, I need to calculate a second point. So I'm going to come back over here and let's see here. We know the vertex is at -3, 4. I'm going to pick an x value very close to -3. So how about -2? So f of -2 is going to be -5 times -2 plus 3 squared plus 4. So I'm taking this function and evaluating it for -2. So then this is what? -5 times -2 plus 3 is 1. 1 squared, we'd have -5 times 1 plus 4. -5 plus 4 is -1. So my second point is at -2, -1. And there it is. And there's the parabola. Now, If for some reason you're having a hard time plotting the points correctly, maybe they've got like, it's like 3.7 or something, you can go over here and just like we did way back at the beginning of this quarter, I can't remember what it was, but we were drawing lines and stuff. We can change the coordinates if we need to. Okay. All right, let's see what we've got here. Anyway, so there's our answer. Any questions on that before we go on to look at today's stuff?
I do have a question on the same assignments. On question, I have a question on question number 8.
Okay, hang on a second here. Number 8 on what? For the
10.4.
10.4. Okay. Give me just a minute here to pull that up. Okay. .4. You said number 8?
Yes.
Okay. I can already see some problems here. But here, let's take a look. Okay. So a question I have is this first graph here. Why do you have so many points graphed?
It wouldn't let me. I tried because I have my points. For the first one, I did -3, and then I got the numbers. I got 9.
Okay.
And then on -2, I got 4.
Right. But you're okay. Did you start with the vertex?
I did.
So your first point should have been 0, 0.
Mm-hmm. Okay. Yeah. Okay.
You always got to plot the vertex first.
Okay.
So I'm not sure. Let's see here. -3, 9, 3, 9. Yeah. So again, to do f of x equals x squared, you'd plot 0, 0, and then like -3, -9, but just the vertex and then another point. Okay.
Okay.
You think, does that take care of it?
Yes, the only one that I was having more issues is that on the s times, well, the 1/6 x
Okay.
squared.
All right, let's take a look at that. So s of x equals 1/6 x squared. Okay, so your vertex is going to be at 0, 0. All right. And then, so then I like maybe put in 1. So s of 1 would be 1/6 times 1 squared, which is 1/6 times 1, which is 1/6. So you got 0, 0, and then 1, 1/6. So what you're going to do is over here, and I can't access it in this mode, but you when you go to graph that, you'd click on 0, 0. Okay, is this the last question you have?
Yes.
Okay, what I want to do then, I'm going to go back to the other screen. Give me just a minute here. Come on. All right. And I'm just going to take okay, let's just use this screen. Okay, so what I would do, I would plot the point 0, 0. Now to plot 1, 1/6, I'm going to go like that, and it's going to go down not where I want it. Okay, so I'm going to come over here, and I'm going to go there and put in 1/6. Okay,
that makes sense.
you good to go?
Yes.
All right. So let me go back here to, we did number 18. Now let's take a look at the new stuff. Okay, so we've been dealing with parabolas in the form of y equals a times x minus h squared plus k. And back up here a little ways, I went through and kind of reviewed how that all works. Now we're going to use a different form, y equals ax squared plus bx plus c, which is the form that we use for the quadratic formula. It's the form that we use when we're factoring by grouping, et cetera, et cetera. If you have a second degree equation in this form, the axis of symmetry is at x equals negative b over 2a. So it's not x equals h. That's if it's in the other form. So axis of symmetry is x equals negative b over 2a, and the vertex is at negative b over 2a. Recall that the x value of the vertex is the same value that you use for the axis of symmetry. And then the corresponding y value, so f of negative b over 2a. All right, how is that going to play out on problem number 20 on the left side there? We've got f of x equals x squared plus 4x plus 3. So a is 1, b is 4, and c is 3. So the axis of symmetry is at x equals negative b over 2a, which is negative 4 over 2 times 1, which is negative 2. So the axis of symmetry is at x equals negative 2. Okay? Any questions about that? The vertex, oops. The vertex is at negative 2 comma f of negative 2. So that would be negative 2 comma, let's see, if I find f of negative 2, that's going to be negative 2 squared plus 4 times negative 2 plus 3, which is 4 minus 8 plus 3, which is negative 1. So the vertex is going to be at negative 2 comma space negative 1. All right. Are we okay with that so far? I'll take that as a yes. Is A positive or negative? Well, the same thing is true with A in this form as it is with A in that form. If A is greater than 0, it opens up. If A is less than 0, it opens down. Here, A is an implied 1, so this thing is going to open upwards. All right, you okay with that?
Can we do another one?
Yep.
Please.
We're going to do another one. We're going to do 21 here. So f of x equals negative x squared plus 6x minus 14. A is negative 1, B is 6, C is negative 14. Let's see here. X equals negative b over 2a would be negative 6 over 2 times negative 1, which is negative 6 over negative 2, which is 3. So the axis of symmetry is at x equals 3. Okay. The vertex is at 3 comma f of 3, which is negative quantity 3 squared plus 6 times 3 minus 14, which is negative 3 squared, which is 9. So negative 9 plus 18 minus 14, which is negative 5, I do believe. let's see here. Yeah. Okay. So the vertex is at -3, comma, space, -5. Okay. A is negative, so it opens downwards. Oh, I messed up. I should have written, I see what I did. Yeah. How did I get a negative there? That should have been a negative. Sorry about that. It was too late. I'd already clicked the button. There we go. Okay.
Okay,
We good to go?
Yes. Do you have another one that could, so I could practice on that one?
Sure.
Similar as that one?
Well, we're going to be doing, hang on. Sure. Let's do 22. It doesn't ask for the axis of symmetry or the whether it opens up or down, but we can still do it. Okay. So we've got x squared plus 2x minus 7. So A is 1, B is 2, C is -7. Okay. Let me ask you this. Does this thing open up or down?
Up.
Okay, good. Because A is greater than 0. All right. So to find the axis of symmetry, you're going to use the formula x equals -b over 2a. So what is that going to give you?
-1.
Because you're going to get -2 over 2 times 1, which is -1. So the axis of symmetry is at x equals -1. All right. Now, it does ask for the vertex. Do we know the x value of the vertex yet?
Yes.
Yes.
What is it?
-1.
Good. How do we find the y value?
Using the formula and plugging
Yep.
-1.
Okay, so do that.
Is it -8?
Yeah, I think so. Let's find out. Ta-da! All righty. We're going to go on, okay?
Yes.
Thank you.
Now, so we know now how to find the axis of symmetry and the vertex in the new form. We're also going to look for X and Y intercepts. Let's go back to graphing straight lines, and you've got something like y equals 3x plus 4. To find the X-intercept, you set y equal to 0. To find the Y-intercept, you set x equal to 0. Do you remember doing that?
Yes.
Yes.
Good. All right. We're going to do the same thing, but now with a second degree equation. So take a look at problem 24. F of x equals x squared minus 2x minus 35. To find the X-intercepts, I would set y equal to 0, right? And y is basically f of x. So I'm going to take this equation right here and solve it to get the X-intercepts. Oops. Okay, you see what I just did? I mean, I haven't actually done anything yet, but I set y equal to 0. Now, to solve this thing, There's a couple of different ways we could solve it, okay? We could factor it, or we could use the quadratic formula. I'm going to go ahead and use the quadratic formula just to kind of review how that works, okay? So A is 1, B is -2, and C is -35. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. X equals 2 plus or minus the square root of 4 plus 140. -4 times 1 is -4 times -35 is +140 all over 2. X equals 2 plus or minus the square root of 144 all over 2. X equals 2 plus or minus the square root of 144 is 12. So that's all over 2. I'll give you a minute to catch up here. So X equals 2 plus 12 over 2, which is 14 over 2, which is 7. X equals 2 minus 12 over 2, which is -10 over 2, which is -5. So the x-intercepts are at 7, 0 and -5, 0. Now, it asks for 2 x-intercepts. Let's see which one we're doing 24. But it wants the smaller x value first. So if I put 7, 0 first, it's going to mark it wrong. So this is -5, 0. And this is 7, 0. Also, a common mistake that students make is they just put in the x value here. This is an ordered pair. So if all you put in is -5, it's going to mark it wrong. You've got to write the ordered pair. Okay. So what did we do? To find x-intercepts, we set y equal to 0, which gave us a second degree equation in standard form. We could factor it, or we could use the quadratic formula. And I used the quadratic formula to get the solutions. So those are the x-intercepts, which I put in here. So far, so good?
Yes.
Yes.
How do you find the y-intercept of this thing? How do you find a y-intercept? Set x equal to 0. So if x is 0, f of 0 is 0 squared minus 2 times 0 minus 35. So it's just going to be the constant. So the y-intercept is 0, -35. Okay, 0, space -35. All right, you good with that?
Can you do another one of those?
I'm going to do another one, but I'm going to do the whole thing. I'm going to do it in the context of the problem. So we're going to find the vertex. We'll actually find the axis of symmetry, the vertex, any x-intercepts, any y-intercepts, and we'll graph it. So we'll do it all here because I want to get, I've got some application problems I want to go through as well. But let's take a look at number 26, okay? So f of x equals x squared plus 8x plus 16. So this is in standard form. A is 1, B is 8, C is 16. Well, let's see. And again, it asks for things, but I'm going to find things beyond that. A is 1, so A is greater than 0. So this thing opens up. Okay? So when we get all done, it better open up. The axis of symmetry is at x equals -b over 2a, which is -8 over 2 times 1, which is -8 over 2, which is -4. So the axis of symmetry is at x equals -4. Okay. I needed to find the x value of the vertex anyway. So you actually have to find the axis of symmetry on the way to getting the vertex. Okay. So now the vertex is -4, comma, f of -4, which is -4 the quantity squared plus 8 times -4 plus 16. -4 the quantity squared is 16, and then minus 32 plus 16 is 0. So the vertex is at -4, 0. Still with me?
Yes.
All right. So we found the vertex. It says X-intercept. Well, to find an X-intercept, what do? You set y equal to 0, right?
Yes.
Okay.
Wouldn't that already be the vertex?
Bingo. Absolutely. See there? Y equals 0, x is -4. So there's your X-intercept. Now, hang on a second. Let's go back. Here, we had 2 X-intercepts. Why is there only one here? Well, I'll show you here in just a bit. Let's find the Y-intercept. So the X-intercept is -4, 0. The Y-intercept is what? F of 0, which is what? 0, 16, right? Because if X is 0, that's 0, that's 0, and all that's left is your constant term. So the vertex is at -4, 0. The X-intercept is at -4, 0. The Y-intercept is at 0, 16. All right, so far so good?
Yes.
Okay, now to graph it, I need 2 points. First the vertex and then another point. Oh, well, these are the same point, but here's another point. So turn it blue. Vertex -4, 0. Oh, notice here the scale, each square is 2 units. So there's the vertex. And then 0, 16 is right there. Let's see. -4, 0, 0, 16. We're good to go. Notice there's only one X-intercept. It's the vertex. Because if the vertex lies on the X-axis, there's only going to be one point of intersection of the X-axis. Okay? That makes sense? We all right with that?
Yes.
All right. I just want to show you a couple things here for a minute. So let's say we graphed that parabola. How many X-intercepts does it have?
One.
2. There's one there. There's
Oh
one
yeah,
there.
there's 2. Yes, 2.
Okay. All right. Let's see here. Let's graph this parabola. Oops. How many X-intercepts does that one have?
None.
None. Right. Right. Good. Okay. Let's see. Let's find one that has 2 X-intercepts. So let's do, well, hang on. Let's do this one. Okay. So f of x equals 2x squared minus 16x plus 30. So A is 2, B is -16, and C is 30. All right. So A equals 2, A is greater than 0, the parabola opens upwards. Okay. So when we get all done, we better have a parabola that opens upwards. X equals -b over 2a. would be negative times negative 16 over 2 times 2, excuse me, which is 16 over 4, which is 4. So the axis of symmetry is x equals 4. Okay. They don't ask for it, but we need to find it anyway because that's the x value of the vertex, right? So the vertex is 4 comma f of 4. Let's find f of 4. 2 times 4 squared minus 16 times 4 plus 30. 2 times 16 minus 64 plus 30. 32 minus 64 plus 30 is what, negative 2. So the vertex is at 4, negative 2. So far, so good.
Yes.
All right. X-intercepts. To find the x-intercept, set y equal to 0. Oops. Every time I push down too hard, it goes to the next screen. Well, I could use the quadratic formula, right? I've got a, b, and c because it's set equal to 0. That's when you'd use the quadratic formula. So x is negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals 16 plus or minus the square root of, let's see, what's negative 16 times negative 16? That's 256 minus 4 times 2 would be negative 8 times 30 minus 240 all over 4. X equals 16 plus or minus the square root of 16 over 4. X equals 16 plus or minus 4 over 4, right? Because the square root of 16 is 4. So we've got x equals 16 plus 4 over 4, which is 20 over 4, which is 5. X equals 16 minus 4 over 4, which is 12 over 4, which is 3. So your x-intercepts are 5, 0, 3, 0. Okay. But I want to put the smaller one first. So I'm going to put 3, 0, and 5, 0. Okay. So far, so good.
Yes.
Now, how do we find the y-intercept? Set x equal to 0. Well, f of 0 is 2 times 0 squared minus 16 times 0 plus 30. So all that's left is 30. So it's going to be at 0, 30. Okay. Any questions so far? All right. We're going to graph this thing. I'm going to start with the vertex. Oh, look at the scale. Each square is 4 units. Oh, also looks like I've got a, this would have been marked wrong because I accidentally hit the comma. I mean the period instead of the comma. Okay. Let's see. All right. Okay, so back here. I'm going to put the vertex, which is at 4, negative 2. And then I'm going to plot one other point. I can use any other point. How about let's use 0, 30. That's right there. Now I'm going to come over here, 4, negative 2, 0, 30. So I, if they didn't land right where I wanted it to, I can adjust it over here. Okay. So there we go. Does it open up just like we hoped it would? Yep, it does. Opens upwards. Axis of symmetry would go right through what, x equals 4. Vertex is at 4, -2. You've got 2 X-intercepts and 1 Y-intercept. All right. Okay, now we're going to look at some application problems. And so I'm going to switch screens here to just this one. Give me just a minute here to get things set up. And let's see here. Okay. All right. Can you see the whiteboard screen?
Yes.
Good, good. Okay. This first problem is about fireworks. It says a fireworks shell is shot up with an initial velocity of 120 feet per second. So it's shot up into the air at 120 feet per second. Its height, S, I don't know why they use S for height, but its height, S, in feet after t seconds is approximated by the equation S equals 120t minus 16t squared. Okay, so for that formula, T stands for time in seconds, S stands for the altitude, the height in feet. Okay. If the shell is designed to explode when it reaches its maximum height, how long after being fired and at what height will the fireworks appear in the sky? All right. First of all, I'm going to rewrite this formula so that it's in standard form. Okay, so I'm going to write it that way. You understand why? So I got my t squared and then t.
Yeah.
Okay.
I do.
Now, what do we know about this thing? Well, A is negative, isn't it? Negative 16. So this thing is going to open downward like that. So here's the ground. We're going to fire this shell into the air. When it reaches its maximum height, it's going to, the fireworks is going to explode. Okay. You understand what's going to happen? They want to know how long after being fired and at what height will the fireworks appear in the sky? They're basically asking us for the vertex, which would be in the form of t comma s, because t would be how much time elapsed till it reached its highest point, its maximum point, and s would be the height at that maximum point. So we need to find the coordinates of the vertex to answer those two questions. Well, how do we do that? Well, let's see here. If we write it in terms of, we've got what, A is negative 16 and B is 120. If we use X equals negative B over 2A, technically it's T equals negative B over 2A, but I'm just going to stick with X for right now. So that's going to be what, negative 120 over 2 times negative 16, which is negative 120 over negative 32. And let's see, 120, oops. Negative 120 divided by negative 32 is 3.75. So the T value of the vertex is 3.75. So that means, when does it reach its maximum height? After 3.75 seconds. Okay, so maximum height. You all right with that?
Yes.
What is that maximum height? It's the S, the output, like the Y value of the vertex. So how do I find that? I put this in for T. And I'm going to go to my calculator and I'm going to go negative 16 times 3.75. squared plus 120 times 3.75, and I get 225, which doesn't quite fit in there because I didn't leave enough room. So it reaches its maximum height after 3.75 seconds. 225 feet is the maximum height. So first question, it says, after how long after being fired and at what height will the fireworks appear in the sky? 3.75 seconds after being fired, 225 feet in the sky, in the air. Okay.
That's pretty fast then, I think.
All righty, next problem. A ball is thrown straight upward from the top of a building with an initial velocity of 32 feet per second. The equation S equals negative 16t squared plus 32t plus 48 gives the height S of the ball in feet, t seconds after it is thrown. So again, t is time in seconds, S is the height of the ball. Find the maximum height reached by the ball and the time it takes for the ball to hit the ground. All right, so what's going on here? We've got this building. We're going to throw a ball straight upward off the building, and then eventually it's going to go down and hit the ground. Okay. They want to know the maximum height and the time. So they want to know the height at the maximum and the time when it hits the ground. Okay, so this is a different question from before. Before they wanted to know the time it reached the height and the height. Here they want the height and the time it reaches the ground. Well, to find the maximum height, we need to find the S value of the vertex, because the vertex is going to be in the form of TS. Okay. So let's see, what have we got? We've got A is negative 16, B is 32, and C is 48. If I use X equals negative B over 2A, that's negative 32 over 2 times negative 16. Let's see here. Which is going to be what? Negative 32 over negative 32, which is 1. So the time is 1 second, but they didn't ask for the time for it to reach the maximum height. But let's put 1 second in. And we get what? Negative 16 plus 32 plus 48, which is going to be 64. So the vertex is at 1, 64. So it takes 1 second to reach its maximum height, and that maximum height is 64 feet. But it says find the maximum height. So max height is 64 feet. Okay. But it doesn't ask how long does it take to reach that. It asks how long does it take for it to hit the ground. Well, when it hits the ground, what's the height? What's S when it hits the ground?
$64 feet.
No, that's up here. What's the height? How high is a ball when it hits the ground? How high above the ground is it? 0. You following that?
Yes, I was laughing earlier.
Okay. Well, how do I find when the height is 0? Oh, you set this equal to 0. Oh, and then you solve that thing. Okay. Either by using the quadratic formula or factoring it. I'm going to use factoring because I can factor out a negative 16. And because it'll take less time. So I get t equals 3, t equals -1. And if I use the quadratic formula, I would have come up with the same results. But can it be t equals -1? No, that's right here, but that point doesn't exist because the ball was thrown starting there. So the time it takes for it to hit the ground, 3 seconds. Okay. Now again, this problem, the first one, they want to know the time it reaches the maximum height and the maximum height. Here they want to know the maximum height and the time it takes to reach the ground. So it's different. Here's another question that's not asked, but I'm going to ask. How high is the ball when it's thrown? How high is the building? Let me ask you this. What time is it right before the ball is thrown? How much time has gone by?
If it takes 1 second to reach the maximum thing, it takes 3 seconds to hit. So it's 2.
Nope, nope.
No? Am I doing it backwards? I wonder.
I follow your logic, but unfortunately, that's not going to work. What
Okay.
time is it? Okay, I'm getting ready to throw a ball up into the air. And right before I throw it, how much time has gone by since I threw the ball?
0.
0. What's the height of the ball when time is 0? 48 feet.
Oh,
So that's how high the building is, or how high, if the person's standing on the building throwing, that's how high the ball is before it's thrown. You see that? All right. Another problem. Let's see here. This says, see the illustration, and what we've got is this. We've got 1,000, oops, what we've got is a lousy, sloppy drawing. We've got 1,000 feet of fence. Okay, so this total of 1,000 feet of fence. And we're going to build a rectangular pen up against the river to keep cows in. Okay, it says the farmer wants to fence 3 sides of a rectangular field with 1,000 feet of fencing. The other side of the rectangle will be a river. If the enclosed area is to be maximum, find the dimensions of the field. First of all, as someone who has been on a cattle ranch, this is a stupid idea. The cows will not necessarily stay out of the river. In fact, they'll probably drown and they'll lose the entire herd, but whatever. Back to the real problem. So we want to build 3 sides of a rectangle with a total of 1,000 feet of fence. All right. What do we know? We know that these 2 sides are equal because they're 2 sides of a rectangle. Okay. Now, make an illustration here. Hang on just a minute. So what we have here is the 3 sides of the rectangle, okay? Can you see that?
Yes.
The whole thing is how long? The whole thing, how long is it?
it would be 1,000 feet of
1,000
fence.
feet, right? Okay. If I take this piece away and this piece away, what have I taken away?
2 X's.
Right. So if this is X and this is X, this would be 1,000 minus 2X. Okay. See where I got that?
Yes.
All right. Now, the area of this thing would be length times width. The area would be length times width. The area would be that. I'm going to write it as a function and I'm going to put it in standard form. So there's my equation that describes the area of that rectangle. All right. So far, so good?
Yes.
I want to maximize the area. So I've got 1,000 feet of fence. I want to create a rectangle, 3 sides of a rectangle that has the maximum area in it because the cows are going to graze in there because there's grass growing in here. Okay, lovely looking grass. There we go. All right. Now, this is a second degree equation. Its graph is a parabola opening downwards because it has a leading coefficient that's negative. So the graph is going to look something like this, where this is X and this is A of X. I want to maximize the area. So if I find the vertex of that parabola, the X value will tell me what X is in terms of the dimensions. The Y value, or the A of X value, will tell me what that maximum area is. Okay. So basically, once again, I need to find the vertex. All these problems asking you to minimize or maximize something, look for the vertex. All right, I'm going to recopy that formula. A of X equals negative 2X squared plus 1,000 X. So A is negative 2 and B is 1,000. C is 0. So X equals what? Oh, X equals negative B over 2A, which is negative 1,000 over 2 times negative 2. Negative 1,000 over negative 4 is positive 250. A of 250 is negative 2 times 250 squared plus 1,000 times 250. And if I go, let's see, negative 2 times 250 squared plus 1,000 times 250, I get 125,000, and that would be square feet. Okay, so the maximum area is 125,000 square feet. It said, if the enclosed area is to be maximum, find the dimensions of the field. Well, we determined that X was 250 when we reached the maximum area. So going back here, this is 250. This is 250. This would be 1,000 minus 2 times 250, which is 500, which would be 500 feet. So the dimensions are 250 feet by 500 feet. Okay. And there you go. All righty. That's it for today. I'll be back at 1:15 with an office hour. Should you have need of me tomorrow, we will review. And then on Friday, we'll take the chapter 10 test. Okie doke. I'm going to stop the recording.